Hi, it's Mr. Anderson, and this is AP Environmental Science Video 29. It's on air pollution. When we think of air pollution today, we think of cities like Beijing. I spent a week there, and I could never see the sun. In this picture, you can see before and after a rain, which has knocked a lot of those chemicals out of the atmosphere. And these chemicals have adverse health effects. And so we saw that in Western Europe. In London in 1952, they had the Great Smog. It was difficult to see, but thousands of people died, and that led to legislation. We had the same problems in North America. And so what is air pollution? It's not only chemicals in the atmosphere, but chemicals that have bad health effects. And since we're breathing it in, it's going to affect our lungs, our heart, and can lead to increased cancer risks. Where are these chemicals coming from? Well, they can be produced naturally. And so we have forest fires and volcanoes that can produce these pollutants. But also we have stationary sources. You can think of those as industrial, like factories. And then we have mobile sources. That would be like cars and buses. And so if they're affecting us negatively, we call these pollutants. And in AP Environmental Science, you simply should memorize the different types of pollutants that I've listed here. Starting with volatile organic compounds, or VOCs. This would be like formaldehyde, gasoline, anything that's organic and can diffuse into the environment. We've got carbon monoxide, this odorless gas. We've got NOx, which is going to be both nitrogen or nitric oxide and nitrogen dioxide. We then have sulfur dioxide produced through the combustion of coal. We then have particulate matter. These are going to be suspended solids. And then finally we have chemicals like lead. These are all primary pollutants. That means they're produced by the source themselves, but they can combine with other chemicals in the atmosphere and produce secondary pollutants. So for example, NOx can produce nitric acid, and sulfur dioxide can produce sulfuric acid. And these combined can produce acid rain, or more generally acid deposition, that has huge impacts on life. And then one of the pollutants that you're probably most familiar with is ozone, that can be produced through sun, and also we need nitrogen dioxide to produce that. And if we can combine a lot of these, then we have smog. It's probably the most famous type of air pollution that you're familiar with, and it's exacerbated by things like temperature inversions. So how do we control air pollution? Well, with regulation is one way. The Clean Air Act in the United States was able to reduce pollutants and save lives. And so technology is able to scrub those pollutants out of the air before it's released. Where's the air pollution coming from? What are the sources? They can be stationary, like this factory. They can be mobile, like all these cars stuck in traffic, or it can be natural. Remember, like giant forest fires can increase the amount of air pollution. But regardless, how do they affect us? It's through our cardiovascular system. It's just like smoking. You can think of it that way. It can lead to lung disease, heart disease, and increased risks of cancer. And so where do we see these health effects most? It's wherever we have industrialization. So clearly it's going to be in places like China, but look over here on Eastern Europe. We have huge amount of industrialization and not a lot of regulation. And so let's go through those primary pollutants again. We've got VOCs, which are volatile organic compounds. An example could be this gasoline that's evaporating into the environment, formaldehyde. If you smell a pine tree, those are VOCs, or organic compounds that are coming off and can lead to things like smog. We've got carbon monoxide, which is produced naturally through photochemical sources, but also can be produced through combustion. All of these sources produce carbon monoxide. We then have NOx, which is going to be nitrogen or nitric oxide, and then nitrogen dioxide. It's this brown gas that contributes to that color that you see in smog. We then have sulfur dioxide. You've probably smelled that if you've ever been around a coal plant. And you can see here that in the U.S. it's going to be restricted to the East Coast generally because we're going to have more industrialization there. And then we have particulate matter. These are going to be small solids. This is from the EPA. So you can think of sand as an example of a particulate, but it's not small enough. And so this is your hair. It's going to be on the order of 50 to 70 microns. And so we're talking about things that are smaller than that. Small sediments that as you breathe it in, the hairs in your nose and respiratory tract don't trap it. It goes into your lungs, and just like smoking, it's stuck there and can lead to other types of diseases. And then we have chemicals like lead. We used to add lead to our gasoline, and there's huge neurological impacts of lead. Now again, these primary pollutants can produce secondary pollutants, and so the nitrogen and the sulfur can lead to nitric acid and sulfuric acid, and these lead to acid rain. It can dissolve statues like this, but more importantly, it changes the pH in the whole food web. web and can impact living systems. And then we have ozone. Ozone, we've talked about before, can be good. And so if we look at the stratosphere, way up here in the stratosphere, remember the ozone, which is produced naturally, is blocking harmful UV rays. But if we move down near the Earth, it produces a tropospheric ozone. We call that bad ozone. And it's one of the large things that contributes to smog, photochemical smog. And so photochemical smog, this is some in Mexico City. You can almost draw a line here and say the smog is below that line. Well, what you're looking at there is a temperature inversion. And so the heat is inverted. Let me show you what that looks like. And so if we have in this environment, the sun is heating the Earth. And so we're going to have the air near the Earth warmer. And so if we look at that gradient, it's going to go from warm at low altitude to cool and then cooler air as we move up. And this gradient is going to move a lot of those pollutants up and then away from that city or wherever they're produced. But sometimes due to currents or wind or just the geography of the city, you can get what's called an inversion. And so instead what we have is a layer of cooler air near the Earth. And so it's inverted. And so as we move up, it gets warmer and then it gets cooler after that. And so what you're doing is you're trapping all those pollutants near the surface of the Earth. They can't move up and they can't move away. And then we start to have chemical reactions going on. And so photochemical smog is caused by these three things: NOx, VOx, and the sun. And so if we look at that chemically, this is nitrogen dioxide. And if you have sunlight, what happens is that will break a free oxygen atom away. Now that free oxygen atom can then combine with atmospheric oxygen and it can produce this ozone. And so what is smog? It's essentially these NOx compounds, and then it's going to be this ozone. But naturally what will happen is that these will spontaneously move back to nitrogen dioxide and regular tropospheric oxygen. And so again, to make smog, we have to not only have NOx and the sun, but we have to have these volatile organic compounds as well. And so how does it work? We break apart that nitrogen dioxide again. So we're producing this nitric oxide, and that will combine with these volatile organic compounds in the atmosphere itself. And so now what happens is that we produce this ozone, but it's not spontaneously going to go back again. And so how do you form smog? We have to have these volatile organic compounds, we have to have this nitrogen dioxide, and then we have to have sunlight. And so areas like Los Angeles, where all of these come together, have a huge amount of smog. How do we prevent it? We prevent the amount of nitrogen dioxide, and we prevent the amount of volatile organic compounds in the atmosphere. Now, how do we eliminate air pollution? We do that through legislation. So we have restrictions on the amount of pollutants. And so the Clean Air Act is probably the most famous one in 1970. And what they did is they put strict standards on these pollutants over here. And so in industry, you're limited on how many of these pollutants you can put into the atmosphere. But how do we do that? Technologically, we can use a catalytic converter. This is essentially grabbing on to that nitrogen dioxide and carbon monoxide that's produced in combustion. We can then use mechanical filters or electrostatic filters like this. They'll produce a gradient and it grabs onto some of these pollutants. We can scrub the air, and we can use wet scrubbers as well. So as the air goes in, the polluted air goes in, we have a mist eliminator. So there's water here, and that water will grab onto a lot of those chemicals. They'll move down into this packing material, and then the clean air is going to go out the other side. And so did you learn the following? Could you pause the video at this point and go through and fill it all out? Well, let me do that for you. It can cause lung disease, heart disease, and then increase cancer risks. Those chemicals could come naturally. They could come stationary or mobile sources. We can control that through the Clean Air Act and technology and regulation. If we look at the pollutants themselves, again, in review, it's VOx, carbon monoxide, NOx. That produces nitric acid. We have sulfur dioxide, particulate matter, and then things like lead. These acids can lead to acid deposition, and the combination of all these produces smog, which is exacerbated by temperatures inversions. And so that's air pollution. It's deadly if we don't regulate it, and I hope that was helpful.